Hi all, in this video we are gonna discuss about tensor operations using PyTorch. So we start by importing the required libraries, and then we start creating a scalar, vector, and a matrix and a random 3D tensor. This is the foundation of all operations in PyTorch. So the dot shape method basically results to help us visualize the dimensions. So here are the dimensions of the various tensors we have created and initialized. So we can visualize slices of tensors. This is very useful when working with image like data. So enops makes reshaping tensors intuitive. For example, converting channel first to channel last for image display. Moving on to tensor reduction. So reduce helps us to summarize tensor content, therefore like finding the max intensity across channels. And moving on to conditional selection with torch.where. So the apply condition element wise, here we zero out negative values. So we're gonna use scatter for fancy indexing to assign values at specific indices. So it's usually great for custom data layouts. And as stride creates overlapping views of tensors without copying memory. So be careful, it's it's gonna create overlapping views of tensors without copying the memory. And moving on to custom activation function with Swish. Implementing Swish from scratch shows how easy it is to create differentiable custom functions. And then moving on to broadcasting for 2D plots. So basically the broadcasting lets us perform element-wise operations across different dimensions like 2D function plots. And then moving on to tensor indexing and slicing. So indexing is powerful. Therefore, grab slices or even selectively pick elements with fancy slicing. And in-place operations like tensor.add.multiply. So therefore, add and multiply in place to save memory and avoid extra computation. Memory sharing with storage. So check if two tensors share common memory. Therefore, a common debugging step when modifying views. So here in this case, it's true. Expanding versus repeating tensors. Expand doesn't copy data, whereas repeat copies the data. So use expand when no actual duplication is needed. And moving on to softmax computation. Implementing softmax manually shows how logits are turned into probabilities. So SVD and eigen decomposition. So explore linear algebra. We can use SVD and eigen decomposition, which gives us insight into our data structure. So plotting the eigenvectors to visualize the direction in which they are aligned. And moving on to QR decomposition. So basically the QR helps with solving linear systems and orthogonal matrix factorization. And then autograd for derivatives. So PyTorch handles automatic differentiation. This makes training neural nets possible. Unfold for image patches. So basically, unfolding breaks an image into patches, which is essential for convolution and vision tasks. Moving on to broadcasting and indexing together. So Broadcasting combined with indexing results in powerful matrix operations that we can perform for image manipulation or as well as for manipulation and stuff. Dynamic reshaping, so easily reshaped squeeze or unsqueezed dimensions as per the model evolves as per the requirements. So let's keep for efficient linear algebra, sparse tensors for memory saving, and VMAX for fast batch processing can be used respectively. And convolution using unfold method. Unfolding is basis of convolution operations. This is what CNNs use internally. FFT and complex number. PyTorch supports complex numbers and FFT, which are perfect for audio signals or physics-based ML, the Fourier transforms. Random sampling. So we can simulate Gaussian or categorical sample directly, which are super useful for generative models. And lastly, custom autograd functions. So advanced users can define custom gradient computation with functions. So these are some of the very useful 25 plus 10 tensor operations which we can perform using PyTorch. Thank you.